Hello everyone, I'm Yogesh, and today we'll be studying about a model that is known as Lotka-Volterra model, and that is a part of Unit 9 of the year of the UGC-NET JRF syllabus. And it is not something that is asked very frequently, it is asked just once or twice in 3 4 years. So, I won't be wasting much of your time here, and I'll be just teaching you this in around 15 17 minutes. Okay, and I hope you will be with me in that particular time. Okay, so one thing I would like to tell you initially is that there are different kind of species interaction. Okay, you must have studied that in your ecology unit in class 12. Okay, so they may be like like symbiosis could be there, commensalism could be there, mutualism could be there, mensualism could be there, predation could be there, competition could be there, and whatnot. Okay, so here we'll be sticking ourselves to the predation. Okay, like in predation, what happens is one of the organism is feeding upon another organism. Okay, so basically this is a kind of positive and negative interaction. Okay, means the one that is feeding is having the positive interaction, and the one that is fed upon is having negative interaction. Okay, so by now you must be knowing like what is a predator and what is a prey. The one that feeds is a predator and the one that is fed upon is prey. Okay, so you guys must be knowing about this till now. Okay, so in Lotka-Volterra model, we basically talks about the predator-prey system or the predator-prey relation only. Okay, so in this we are going to study about two differential equations. So those of you who are having the biology background, means those of you who are not aware of the differentiation per se, so you need not to worry because I'm going to explain you that in quite a simplistic way and you'll be able to understand that quite well. Okay, so there are just two equations. Okay, so the first one will be relating to the population of predator, means that means how the population of a predator is going to decrease or increase, and another equation means the equation number two will be related to the population of prey, means how the population of prey will be changing. Okay, so that is something that we are going to study, and we have to study both of the equation in a significant manner, and we have to study both of them at same time. Okay, so now let us move. Okay, so we are considering here some assumptions. So basically, there are two assumptions that we are considering here. So the first assumption is that prey is having ample food supply. That simply means that the food supply is not something that will actually be changing the prey amount or the number of prey. Because if the food is not properly available, then it doesn't matter what the population of predator is, the population of prey is going to decline only. Okay, and the second factor is that the predator is feeding upon the prey only and on nothing else. Okay, so basically these were the two assumptions that we are considering here. Okay, okay, so uh, let us take some example of prey and predator relationship, and one of them will be using in our upcoming slides. Okay, so first one is a rabbit and wolves. Here, rabbit is a prey and wolves are predator. Definitely, you are correct here. Okay, and simply the food, fish, and sharks. So the sharks are predator, and these are prey. Okay, so here ladybug and aphids, predator, prey. Then here also the amoebas are predator and those are prey. Okay, so these were the examples, and in our upcoming slides, we are going to take the example of the first one. Okay, in an isolated forest, there are just rabbit and wolves. Okay, so in this model, basically, we have two dependent variables. Now, what are dependent variables? Firstly, so variables are something that are going to change. Suppose we are talking about the population of rabbit. So, is that a variable or a constant? Means that is going to be stay fixed or that is going to change? Definitely, that is going to change. And what about the population of wolf? Will that remain same? No, that is going to change. So, those are the two variables, meaning the number of fox or the number of wolf and the number of rabbit. Those are the two variables. And why we are considering them dependent? Because the number of rabbit will always be dependent upon the number of wolf. Okay, so that's why we are saying that we are having two dependent variables with us, and both are the function of time. Now, what is the meaning of the function of time? That both are basically changing with time. So it doesn't mean that they will remain same all over. Okay, first thing is that they're dependent upon each other. Second thing, they are changing with time. So that simply means that they are a function of time. Okay, and if we are writing first function over here, that is RT simply means that the population of rabbit with respect to time as a function of time. Another one is WT, means population of wolf as a function of time. Okay, so now let us move to our first situation. Okay, so suppose there are no predator, means rabbit are free to roam wherever they want to, they are free to do whatever they want to. Okay, they can eat whatever they want. Okay, means they are free to do whatever they want. Okay, so what will happen then? So basically they will grow, means they will have show the growth, they will be having ample amount of food available with them, so they will show exponential growth. So suppose initially there were two rabbits, okay, one male, one female. So what will happen then is they will have two children. Okay, they will grow into four, then they will grow into eight, then into 16, 32, 64, and they will keep on increasing. So they will grow like 2 to the power, and this is known as the exponential growth. Exponential simply means like 2 to the power n. Here n is exponent. Okay, exponent, or we can say power. Okay, so that is the exponential growth. So what will happen? So if we are considering for a small change of the population of rabbit, means the population of rabbit is changing with the time. Okay, so how will we write that? In mathematics, we use something called derivatives. Okay, so here we will be using the differentiation like dr by dt. Here, dr simply denotes small change in the population of rabbits. Suppose R2 minus R1, final population of rabbit and the initial population of rabbit. So that is denoted by dr. And time t2 minus t1. So that will be denoted by dt. So that is the meaning of dr by dt. And we can simply say that dr by dt means the rate of change of the population of rabbit with respect to the change of time will directly be dependent upon the population of rabbit. More will be the number of rabbit, more will be the change. Okay, so it will be dependent upon the number of rabbit. And this is known as the proportionality sign. And whenever we need to remove this proportionality sign, we have to use some proportionality constant. So here what we will be doing is dr by dt equal to, we will be using a proportionality constant here, k, small k, okay, and equal to r. So this is our natural growth equation for prey if there are no predators. Okay, so that is something that we know by now. Okay, so if there are no prey, initially we said that there are no predators, means the rabbit are free to do whatever they want to. Now we are saying that there are no rabbits and there are only preys. So what will happen to prey? They are not having something to eat now. Okay, so definitely we know by now that their population is going to decrease. But how will that decrease? What will be the rate of that decrease? So that is something that we are going to study here. Okay, I already told you that whenever we have to find out a small change in something, then we use differentiation. Okay, so small change means dw by dt, rate of change of wolf with respect to time, will be directly dependent upon the population of wolf. Why directly proportional? If there are more number of wolves, then definitely those will be putting more pressure on the already declining resources. Okay, so that's why. Okay, so whenever we remove this proportionality sign, what we use is a constant. So dw by dt is equal to, now we are using a proportionality constant, that is r. Okay, and then we use w. Okay, so this is clear up to now, but we all know that this is going to decline. The population is going to decline, and if the population is declining, definitely the rate will also be declining somewhat. Okay, so this negative sign here denotes that the population is declining. Okay, so we are clear up to now. Okay, so this is our second equation. So here we have used one constant, that is r, and r is a positive constant. Keep it in mind that this negative sign is not with r, rather this negative sign shows decline. Okay, and in the previous equation, we also said that we were using a constant means k. K is also a positive constant. And in our upcoming slide, we will be studying about two more constant that is a and another one is b. So those two will also be the positive constant. So all the four constants means k, then r, then a and b. So all four will always be positive constants. Okay, so I guess we are clear up to now. So here we studied about two situations. First one is that there are no predator, and another one there are no prey. However, in the natural ecosystem, both of them are present. Okay, means there will be predator, there will be prey, and predator will be feeding upon prey. Okay, so the natural growth will be somehow declining. So initially the rabbits were growing like anything. Okay, but now if the predator is there, then some amount of those rabbits which were growing like anything will be eaten up by the wolf. Okay, so I guess this is clear to you. Okay, so another thing that we have to consider is if the rabbit is going to be eaten up by wolf, then rabbit and the wolf must interact. So suppose the rabbit is hiding somewhere and you are considering that wolf will eat it. No, there are no chances of rabbit being eaten up by the wolf. Why? Because they are not interacting. Okay, means they should meet each other. Then only the wolf will be able to eat the rabbit. Okay, so the interaction is must. So whenever we're considering about the eating capacity, means how fast the wolf will be able to eat the rabbit. So that basically relates to the interaction, and interaction is dependent upon the product of their numbers. So whenever we consider about the interaction, okay, so that is basically directly proportional to the product of both of them, means number of rabbit and the number of wolf. Okay, so more the number of rabbit, more will be the interaction, more will be the eaten up numbers. Okay, and if we consider the number of wolves, then more will be the number of wolf, more of the wolf will be there to eat the rabbits. So this is it. And whenever we remove the proportionality constant, we use some sort of what? Some sort of what? Constant, definitely. So here we will be using a constant that is A. So this becomes ARW. Okay, I guess this is clear. Okay, so basically we can form two equations here. So initially we knew that dr by dt is equal to kr. So this is something that happens when there are no predators. But since in this case predators are there and those are going to eat some of these rabbits. Okay, so what will happen is the rabbit population will be declining by some extent. Okay, so since this is a decline, we have to use negative sign over here. And what will be the rate of decline? That will be actually governed by the product of their numbers minus A. A is the sign that we use. Okay, so product. Okay, so that's how we will be forming this equation. And how does the ARW come? So I have shown this here. So it basically relates to the interaction and it is actually the natural growth. So this is equation number one. And whenever we have to form the equation number two, we have to go by similar form. Okay, dw by dt. Okay, so that is basically equal to minus rw. So this is natural growth rate or natural decline rate. However, we know that the wolf is going to eat some of the rabbit, and that's how the population of wolf is going to increase. So for an increase, we'll be using positive sign and the interaction will be shown by RW and the constant that we have used here is B. Okay, so these are the two equations, the differential equation. First one is this, second one is this. So these two equations are the ones that are known as Lotka-Volterra equations, and these are the equations which are actually the basis of the Lotka-Volterra model. I guess you are knowing this by now. And the term ARW. Okay, so it basically decreases the natural growth rate of prey. Okay, I use this equation if you remember dr by dt is equal to K, then R minus ARW. So we are talking about this. So basically it decreases the population of what? Prey, means of rabbit. Okay, and this BRW increases the natural growth rate of predators. So we have used dW by dt is equal to minus RW plus maybe R. W. So this is here. So it increases the population of wolf. Okay, so we are done up to now. Okay, so these two equation basically forms the Lotka-Volterra equation, and Vito Volterra was the mathematician who proposed this equation initially. Okay, and yes, he used the shark and the four fish. Here, four fish was prey and shark was predator in the Adriatic Sea. Okay, so these are the two equations that we need to work upon. Okay, and we need to like solve them at one time only. Means we have to solve them simultaneously. Okay, so here we are having one question, and this will suffice our work for this Lotka-Volterra model. Okay, so I'm just writing the equations again so that you will be able to put the values in the equation by yourself. Okay, so the first equation that we used was, okay, dr by dt means the rate of change of rabbit with respect to time was equal to k, then r, then it was declining, okay, due to the interaction minus a r w. Okay, so that was the first equation. Another equation that we used was dw by dt means rate of the change of the wolf population with respect to time was shown by minus r W minus B. Sorry, this was plus B R W. Here B R K and A are the positive constant, and now we just need to put the values here. Okay, so we can put the values and we can get the solution. Okay, so if we are considering that there is no rate of change, okay, if there is no rate of change, then definitely we can find out the value of R, means the population of rabbit as of now, and the population of wolf as of now. Okay, so if there is no rate of change, then what does it mean? Let us find out. So if there is no rate of change means that is equal to zeros. So if we consider it to be zero, then what will happen is that r will be, what will happen is we can say that let's take r common. Okay, r k minus a w. So this is the first equation is equal to 0, and from here we can take w as common. W is equal to minus r plus b r equal to 0. Okay, so that is something. Okay, so now from this what we can get is then will it will go to go means right hand side, it will go in the division and the r will be equal to 0. Okay, r will be equal to 0, and similarly here also. Okay, so when this, when this will go this side, it will be also b becomes 0 and w will become 0. So it is first case. So in another case what can happen is, okay, so in another case what can happen is this r can go here, so it will become 0. So here I am solving it, r goes right hand side, it will become 0. So we will be having k minus aw is equal to 0. So k is equal to AW. So we are having the value of k, we are having the value of A. Now we can find out the value of W. So W is equal to k by A. So that's how the number of wolf can be counted. And similarly, we can use that equation here, means minus R plus BR is equal to 0. And we can write it as BR is equal to R. So from here we can find out the population of rabbit because we know the value of B and R. So this is something, okay, that is important for us to find out. So this was all about the model. Okay, so we need not to go into depth of the differentiation per se. Okay, because these questions are not asked very frequently. So this is sufficient for your questions perspective. Okay, and I guess you must have studied by you must have understood this by now. So I want to repeat these two things again. Okay, so basically here we are using two differential equations. So first one relates to the population of rabbit, means or to the prey, and another one relates to the population of predator, that means wolf. Okay, so what will be the effect of the decline in the population of rabbit on wolf? So that is something that we are going to study in this. So we are going to find out the predator-prey relationship. Okay, so thank you very much, guys. In case you face any kind of problem, then just let me know, comment in the comment box. And thank you very much, guys. I guess you must be knowing this by now. Thank you.